asked me to solve questions 21 through 24, which use this data from the toucan. So the toucan is the largest member of the toucan family, and it possesses the largest beak relative to the body size of all birds. This exaggerated feature has received various interpretations, such as being more refined adaptation for feeding. However, the large surface area may also be an important mechanism for radiating heat, i.e. cooling the bird as the outdoor temperature increases. I recently got back from Belize, and there were a ton of these toucans. I'll try and make the ones I saw the thumbnail for this. So the table contains data for beak heat loss as a percentage of total body heat from all sources at various temperatures in Celsius. The data shows that beak heat loss is higher at higher temperatures and that the relationship is roughly linear. So here's our data set. And it's asking me, what is the equation of the least squares regression line for predicting beak heat loss as a percentage of total body heat loss from all sources from temperature? Use decimal notation and give the values of the intercept and the slope to 3 decimal places, and then answer a question below. So the problem with this data set, unlike in some of our other problems, is I can't download it. There isn't a button for me to download. So I need to figure out a way to get this into R. And an easy way, well, I thought relatively easy way to do that, would be to make an Excel file. So I looked at this Excel file I'd given us for a project before. I think this was the last project. And I saw that there was an indices and then, and then all the variables. So what I did was I took the data that we were given, I gave it an index, I copied all the temperatures from the table. I can go ahead and close this. Don't save. I copied all the temperatures from the table so you can see, okay, 1535, 1635. I copied all the data and I made sure to save this as a CSV. That's the way R likes to take data, is saved as a CSV. So I saved that. And then I can go ahead and input this in R in order to answer my questions. So I go to R. There it is. I go to R and I call this data set from my desktop and I name it Toucan. And then just to make sure it worked, I type in Toucan to see if my whole data set prints. And as you can see, we've got our temperature, and it did change the name of my data to put periods in between so now I can still call it. So for problem 21, the question was, we want to find the equation for least squares regression line for predicting beak heat loss from temperature. So temperature is going to be our x, and heat loss from our beak is going to be our y. So I'm going to use the command lm, which is the linear model command. First thing I want to do is put my y. So that's going to be toucan percent heat loss from beak. I believe it's a tilde. It might be a comma. If this doesn't work, we'll try a comma. Toucan temperature. So we'll go ahead and run that code. And it worked, right? So we've got our wonderful x and y intercept, and it wants us to do it to 3 decimal places. So I'd have 0.478 as my intercept and 2.068 as my slope. So I've got 0.4, of course I just forgot it, 78 plus 2.068 x. So that's going to be the equation for my slope. And remember, this is percentage, right? Percent heat loss from beak. So for every degree, we need to pick which one of these is correct. So we know it's going to be going up 2.0, so about 2.1%, right? It's increasing. So I mean, like, that means it's losing more. So for every degree Celsius, the toucan will lose, so these 2 less ones we can ignore, it's going to lose more heat through its beak, and it's not the 0.5 because that's our intercept. So this would be our correct answer. So we'll check that. Woohoo, go team. Next, it wants us to use this least squares regression line to predict the heat loss at a temperature of 25 degrees Celsius. So we go back to R, and I say, okay, I have a y-intercept of 0.4779, and then my slope changes to 0.067% by temperature. So I'm going to multiply this by 25 because I'm in degrees Celsius, and that gives me 52.16. So I have 52.16, but it says 1 decimal place. So I've got 52.2 would be our predicted heat loss for these toucans at 25 degrees Celsius. We're also correct. So, what percent of variation in beak loss is explained by the straight line relationship with temperature? We need to give our answer to at least 2 decimal places. Well, the percent variation, that's going to be our R squared. So I need to find the correlation. So let's go ahead and find the correlation. So that's going to be correlation of toucan, percent heat loss from beak, comma, toucan, and it might be tilde, but we can change it, temperature. So there I've got my correlation, and what I need to do is I need to square this. This is my R, and I'm going to square this. So I'm going to copy it, because, you know, copy paste is your friend. And I'm going to square it. I'm going to multiply it by itself. This gives us R squared. And I've got 0.8344. So that would be 83.44%. We can check our answer. Cool, we're right again. Next, I want to find the correlation between R between heat loss and temperature. Give your answer to 3 decimal places. Well, we actually already did this when we were trying to solve the last problem. It's 0.913. And then, do we know whether the sign of R is positive or negative? Well, it's the correlate and what the correlation is. Well, our correlation is positive because the least squares regression line has positive slope. So this is going to be our correct answer. We'll check this. Good job. So that's problems 21 through 24. Stay tuned. I think I'm going to include a video of the toucans I saw in Belize.